Hi guys, in this video we'll be discussing the problem 2577 from Leetcode. The problem's name is minimum time to visit a cell in the grid. So the problem states that you are given a m into n matrix grid consisting of non-negative integers where each of these values actually represent the minimum time required to be able to visit the cell at the location, which means that you can visit the cell only when the time you visit it is greater than or equal to the current time, right? Or is greater than or equal to the time at this particular location. So you are standing in the top left cell, that is the cell at location 0, 0, right? And you are standing over there at time equal to 0, right? Now, if you want to visit a cell, so from 0, 0, you can only go to the to the right cell or to the cell at the bottom, right? Okay. So if you want to visit that cell, so it will take you 1 second. Now, if you take 1 second and reach over here, then by that time your current time would be 1, and the time you can or the minimum time you can visit this cell is actually 1 itself. So you can say, okay, I can go over here. Can you directly go from 0 to 5? No, you can't, because at you were over here at time equal to 0, right? Now you want to say that I want to reach this particular cell at time equal to 1. So that's not possible, and hence you can say that, okay, I cannot go directly over here. You can go to here, from here you can go to here, because you will be over here at time equal to 1. Then you can say that I can like spend 1 more second to go to this particular cell to my beneath, and I'll reach there at time equal to 2. Now since 2 is greater than equal to 1, so you can go over there. So that's it about the question. Let's take for example, you're over here at time equal to 0, and now you want to go to the next cell. So can you go to this cell? No, you can't. Can I go to this cell? No, I can't. So I am blocked over here. I cannot go to any of the cells which are adjacent to me. So I'll have to print -1 because it's not possible for me to reach the end cell. But in case if it's possible to reach the end cell, then I have to print the minimum time required to reach the end cell. So that's it about the problem. Now let's try to understand the intuition behind it. Now the first thing is that, is it always possible to reach the end cell? Like, can I always reach from 0, 0 to, let's say, n-1, m-1? No, that's definitely not the case. We already discussed a sample solution, and wherein we were not able to reach the end cell. The only case wherein this kind of a scenario would happen is if the cell just to my right, or standing at 0, 0, the cell to my right is actually 0, 1, or the cell to my beneath, that is 1, 0. If both of these values are actually greater than 1, only in that kind of a scenario I'll be blocked in 0, 0 itself, and I'll not be able to go to any other cell. Now what if I'm talking of another cell? So let's say any random cell, let's call it R and C. Would I be able to go to all of its neighbors? Yes, definitely. Now let me prove this thing to you. Now let's say R and in order to get to R and C, if R comma C is not equal to 0, 0, so that's the exception case we are already handling in the start itself. So if it's not equal to 0, 0, then definitely it has some parent. By parent I mean the cell from where we actually reached to R and C in the first place, right? So let's call this particular cell maybe as R0 C0. Now let's say RC wants to go to another cell R2 C2. Now what I'll do is that I'll check that if this distance, so let's say the grid of R2 C2 has some value y, the grid of RC, or let's say the current time itself, grid doesn't matter over here. So let's say the current time is maybe something like x, right? Now if x plus 1 is greater than or equal to y, then definitely I can go. So that's base case, so that I know. But what if x plus 1 is less than y? Then in that case what would happen? So by x plus 1 I mean the current time plus 1 is less than the time you require to the minimum time you require to go to this particular node. What would I do in that case? So I'll say that I already have a parent which was R0 C0. So over here I was having a parent that is R0 C0. I'll travel to this. Would it be possible for me to travel to this? Yes, it would be possible, because you already came from that parent. So definitely the time to visit that parent is actually smaller than the current time. So I'll go to this parent, then I'll come back over here, then I'll again go to this parent, I'll come back over here. So I'm basically making round trips. Now round trips actually take me even time to proceed, right? So a single round trip would cost me 1 plus 1 unit. So it will cost me 2 seconds or 2 units of time. Now let's say I make some A round trips, right? So A number of round trips is what I'm making. So it will take me A into 2 time, right? So I'll keep making these round trips till the time this equation gets satisfied. So x is the current time, right? In each of the round trip, I'm actually increasing it by 2. So I want to make this equation. So the current time of, after a round trips would become x plus a into 2, right? Where x was the initial time I visited this particular node at RC, right? So this would be the time after a round trips. I just want that x plus a into 2 plus 1 becomes greater than or equal to y. Till time I'm not reaching this, I'll keep incrementing my a, or I'll keep incrementing my round trips. Now after certain time, this definitely would get satisfied, because y is actually a finite value over here. So I'll just have to check for this. Now the only point of consideration is, because you are making round trips, so let's say from, okay, let's just give it some values. So from, okay, let's call it x. So this is the node x, this is the node y, this is the node, let's say p. So parent node is named p, this is the node x, this is node y. So we were making round trips over here, right? And let's say at over here the time was equal to 6. So the current time you visited over here was actually 6. The time you required to visit over here was equal to 8. So tx was equal to 6, or current time tc is equal to 6. So now what you will do is that you will make a round trip, because tc plus 1 is not greater than or equal to 8, right? So you'll have to make round trips. So even if you make a single round trip, even in that case, the current time would become tc plus 2. That would be 6 plus 2, that would be 8. You require 1 more second to go over here. So now you'll reach the node y at time equal to 9. Cool. So that is something to note, that if the difference between your x and y, or y and x, or the node you are going to travel to, and the current time you are having, if it's a modulus 2 equal to 0, if it's like divisible by 2, then already you'll be using some operations to, or you'll be using some time to make the round trip, that actually also would be a multiple of 2 itself, right? So 1 extra unit would be required to reach the node at y. Now let's say if the difference was actually 3, so let's say it was 9 and this was 6, then in that case tc would have become 8 after one of the round trip, and then you could have said that I'll use 1 unit of time to reach y. In that case you would have reached y at time equal to 9 itself. So that would have been optimal. So the only check over here is that if the difference between the time of x and y, if it's a modulus of 2, or if it's like divisible by 2, if it's an even number, in that case you'll be utilizing 1 extra time, or you'll be reaching at y at the time ty plus 1. So that's it for the question. Other than that, you simply have to use the Dijkstra to implement it. Let's go through the code also. So firstly, what I'm doing is that I'm saying that if my like the lower child or the right child from my starting position, if they're greater than 1, then there's no way I can even proceed, right? So in that case, I'll print -1 directly. Else this is the general Dijkstra that we use. So I'm not explaining the Dijkstra per se. If you want a video on Dijkstra, you can definitely comment below. I'll like try to find some time slots for that even. Okay, so the only difference over here is that I'm checking for the wait time. Now, as I told you that if the time between the current node and the node if the current time and the time you require to go to the next node, if it's divisible by 2, in that case, you'll have to add 1 to the time, right? So that's what I'm calling wait time over here. Now, what you'll have to do is that you'll have to push this particular node into the map. So over here, the time at which you'll reach the particular node would be either the time plus 1, either the current time plus 1, or if your current time is actually less than the node that is right to you, or current time plus 1 is less than the node that is next to you, in that case you'll be using the wait time plus whatever the grid time is, right? And then you'll be mentioning the cells. Cool. So that's it for the solution. I hope you understood the solution well. If there's still any doubts, you can let me know in the comment section below. Thanks a lot, guys.